Okay, so here you have Iago. Well, we don't have Iago here. We have had some technical issues with the car. Here you have two of the best forensic experts in Europe and all over the world. The best, by the way. So you introduce yourselves and check the time, please. So welcome to this speech. We've called it around a DFIR investigation the easy way. Revealer Toolkit. So we've been using this for quite a long time. It has been used by us for quite a long time. We started with some scripts and it has ended up with this module that we're introducing today. It's a tool that we use every single day. We use it at our forensics lab, and it has been tested and it has been designed to take into account all those mistakes and situations that we found for many years and in many different cases. So as Roman was saying, I'm Abraham Pasamar, the manager of Scientific Company, and Juan Vera has a PhD in telecommunications, and that's his dog. So we're going to explain the tool, both of us. It's very important to take into account that throughout all these years of forensic analysis in the lab, we've been seeing many different things. So it's very important to find the repetitive procedures, and these cases take different situations into account, and we've been able to find what are the things that are repeated and the things that we will need. Sometimes we will need some things, and other times we'll need other things. So every case is different, but there are many things that are common, and this is very important in order to build the tool. The idea is to take into account all the different analysts and collaborations, because we are a company where we don't have an analyst that is developing just a single case. There are many different things and they can collaborate on the different cases. So we are taking all these things into account when designing this tool. So what are the alternatives in the market in order to conduct these forensic analysis? So there are tools like, for example, business solutions, NCase, FTK, OS Forensics, or Nearsoft that let us access the incident response scenarios so that we can act on Windows and we are able to pick things from there. So let's see them on the fly so that you can have an idea of how they work. This is a snapshot of the NK solution. These are proprietary solutions. You have to pay for them. This is FTK, Xways, or other alternative tools that exist in the market. This would be Nearsoft. That is this tool that is more focused on Windows and incident response and live analysis scenes, scenarios where you have to tackle an artifact triggering in a quick way. So there are many artifacts, but it's stuck a little bit to that, limited to that. We have the proprietary tools, except Nearsoft, but we have an open source alternative here that's called Autopsy. It works. It is supported by its SloydKit, and we also have this in the tool that we're going to see. The difference is with the evolution that we've seen in SloydKit that moved from an older dog to this current dog, has become into a tool with which you can visualize data in a quite interesting way. It's quite visual, with a quite nice presentation, but it's true that it's not very configurable, so you don't have control on what the tool is doing in the background. It's a tool focused on the final result. There are other alternatives, and this looks much more similar to the thing that we are going to present that go towards this direction. And this is a matter of joy for us because we are doing something right, both in terms of design and tool. With the tool Squeeper. Squeeper uses a design that is quite similar to the one that we're going to show. So we like open source tools because at the forensic level we want to control processes and output, and this is why we like the terminal so much. We like to use command line tools because these structured output can be combined between one tools and others. So, and many tools like the ones that I've shown before, it's much more complicated because it is limited to what that tool enables you to do. All these open source tools are quite useful for many forensic processes, and most of them are integrated up to a higher or lower extent in our project. Keep in mind that we want to link in a continuous way the usage of these tools and to play with outputs that we are able to control. For example, we would like to use grabs. That's the best forensic tool, and this is what we want to integrate. If we are able to control that flow of data, well, this would let us combine different tools. At a typical investigation or research, these have been the problems that we've found. So a new analyst comes along, he's new at the team, and he says, well, let's going to conduct a forensic investigation. This is one example of what could happen. I want to set an image. There's a disk image, and he sets it. After that, he says, well, I'm going to create a timeline that it is the export of the forensic artifact, and for example FLS plus MacTime. After that, maybe he adds the Windows events, things that the machine can tell me that have happened, and the analyst continues with the Windows registry to transform this registry to have it in text format. So we would do a parsing of artifacts in order to analyze all of them. And what happens? He has to do grabs. He needs to look in all the artifacts. Some of them are binary that have been exported to text format. He has to do grabs in order to find lines or elements that match the keywords. After that, he goes on doing grabs, because it's a loop that feeds back the investigation. You have databases, you have the SQLite, and you continue parsing everything. He parses, analyzes, and he says, well, I have an email. So you look for the solution. So I parse the email and have the data. And after that, he says, well, there are things that have been deleted, or maybe, well, it seems so. So let's see the shadow copies, the restore points of the device. And out of all the artifacts parsed by the registry, he forgot a hive, so he needs to go back. He has to parse that hive, and he needs to analyze that hive again. But when he's ending with a stage, he forgot whether he found the word monkey or not, and he doesn't remember if he used it or not. And he realizes that maybe he threw it in case insensitive, and he has to repeat the research because he should have used case insensitive in order to find all the occurrences. And when he's going to do, he forgets about the flag of that case insensitive, and he needs to look it up at documentation. So this is a quick example for you to understand the process and to see what are the things that we are doing. He parsed the artifact, now he forgets about something. There are many things in a forensic investigation. We need to take all these things into account, and the vast majority of them will need them in almost every case. Okay, same happens with a recovery petition, or now there's a new colleague and he starts to work with him, and he has to explain everything that he's been doing up to then, and everybody is not as tidy, and you have to tell him, no, look at this, don't you look at this because this is a waste of time. So such an investigation is complex, especially when there are several people. So where does this take us to the Revealer Toolkit? In order to avoid this, we've been building different pieces that we've been integrating into a tool. So now my colleague Juan B will continue with it. Okay, so this is the scenario that we find in our investigations, in our analysis, in a constant way. We start the analysis, and sometimes, especially when we are not very well organized, we keep the outputs at different places in a different way, or we use different techniques or different tools. And this is where we want to help with this tool, with this RVT2, especially because we are a company where we manage many forensic cases. We have many analysts, and we want them to follow the same line, more or less, in order to be able to have good results and to get to the end of our investigation. So this is the motivation of our system. We've been using open source tools for many years, and we want to return the world some things, a little bit of what we've been taking advantage of. So this is why we've given control to the analyst on the commands that he's executing about its execution, and we want to let him use the analysis tools that he deems necessary for each of the cases. Open source, we want to use open source tools because we believe in open source. We think the analysis needs to be open, and that this means that people should be able to perform the same analysis that we do to reach the same results. And we want to define procedures, not because they are the best procedures in the world, but at least to have documented procedures that can be followed one after another. And these are the module the model chains that we want to follow. Apart from that, we want to automate tasks that are repetitive tasks. For example, if we start the same way, we always perform the researches in the same way. And in order to prevent human mistakes, sometimes we make mistakes. We do not have the commands that that should be applicable, or the ones that we have to use. And this way, we can minimize this bug probability. And last but not least, the execution of common tasks for all cases. Regarding the open source, we need to take into account that as far as it is open source, it can be audited, and it is very important from a forensic point of view. So when we are presenting an electronic evidence, in our opinion, in the opinion of many experts, the fact that it's an open and auditable tool lets us automate that way of working, and we are able to see that this evidence is, well, it's very clear how it has been obtained. At a more close tools, it's very difficult to find this sometimes. Maybe we get the same results, but we can't guarantee that it's going to be the case in every scenario, and we think that it's very convenient that the open source contributes this capability to audit, so that we can see that there's no other option. Okay, so this is a description. Well, this is an overview of our system, of our solution. This is RVT2. Our RVT2. So it's a predefined chain of commands that will be run on forensic images. We have the possibility of executing the same procedures and commands in every case. It's a converter between anything, between any artifact, the Windows artifacts that we'll see right now, or Android iOS, to JSON. JSON is a format with a very high semantic capability that lets us describe the artifacts with a very high level of detail, but it has a very clear advantage for us. And it is that we can do greps. We can look for what we want to find, or what we're looking for through grep, through command line, and we can send this JSON filters, or we can send it to other tools, because JSON's a format that's supported by many tools. So the fact that of having these commands, we think there's a great advantage so that the analyst can perform the analysis on its way with the most convenient tools. And it is an interface to many open source tools that are very well known. We don't have to talk about them. We do not have to defend them, like the ones that we can see here: RecReaper, SQLite, Elasticsearch, etc. So it's an interface for these type of tools. And this is where we think that we make the difference. It's possible to structure the output from the tools of all the jobs in a very well structured way. And this way we can have a new analyst in the case to know what has been done, what is still missing, the researches that already have been done, or the artifacts that have been analyzed. And last but not least, in order to enable the audits, we have a login system in order to to see what has happened up to that moment. So this will be a key idea throughout the whole project. We think that the hard work, the routine work, should be done by the machine, the defined projects, etc. And this way, we can leave more time to more time for the analyst to think. We give some data to the user, and the analyst can start working on the case without worrying about what commands are being executed in the background, because he knows them, both because of his expertise and because he has repeated them in an automatic way many times. This project, well, we are not making it up. It has a long history behind of it. The first comic appeared in 2008, so now it's almost 15 years. We have a history of developers. I hope we have not forgotten about anybody. I think that people in the audience are on this list. So for you to see that this is not a project that we have invented right now, it has a long history. There have been many people working on it. In fact, the Revealer Toolkit starts from some scripts that in an original way were baptized by Manuel Gines in Bas and Pels. He started to call them Chanchullo's Revealer, because in the forensic activity you always look for any illegal situation. So we call this as Chanchullo's Revealer. So it was not a very serious name, so we removed it from the equation, but we kept that Revealer. And this is why both versions have been called Revealer Toolkit. So I would like to say thank you to all of you, because after all these years, all these people have collaborated. Luis Gomez, Jose Navarro, who did it in a more structured way, Sara Rincon, Jose Selvi, myself. I've done some lines, Manuel Cardona, who has taken the code to Python, and he's the author of the first version in Python. This has evolved with Carlos Fernandez, Imanol, who is around too. We have Eduardo Sano, Arnau Estevanel, Neus Bosch, and Pau Garcia, and Juan Vera, of course, who have contributed everything to for the system to be what it is right now. So let's get into further technical detail in terms of our system. This is to have some general point of view. After that, we will get into case studies that are funnier. This is just an introduction for you to see how we organize ourselves and what we have behind. We think that, well, this can be useful for many companies. We've reached many companies and organizations that have directories that have cases. We have what we call a morgue. Morgue is just to keep the forensic tradition. This is where we put the corpses to analyze them, and within this morgue is where we have each case. We don't have just a morgue. Depending on the case, depending on the analysts that are working on it, there could be an external morgue, a morgue where the customers have access to, or several morgues. In fact, we have some servers with a morgue each. So we need to be able to move these cases among different morgues depending on each case's needs, and we take this into account in our system. Although the output is highly structured, it is configurable enough in order to adapt to the different situations that we have in the case. So once we are in the case, we have a folder structure or a source directory. This is the organization that is useful for us. We have a structure. I won't get into each directory, but for us, this is a very useful structure. We understand that the structure does have to be useful for other companies. So although this is our proposal, it's 100% configurable. There's a setting system that lets you include every output, every file at the most convenient folder for the company. In the end, what we are doing is to execute modules. These modules call open source modules. They call other modules that can link between themselves or among themselves, and they could do pipe to well, yeah, they can do pipe, and the modules are highly specialized pieces that do a very simple thing, and we have plenty of them. Now we have around 100 modules, and all these modules are linked in what we call jobs. And this is what the analysis executes. In fact, the forensic analysis, in the end, it's a job succession. Now we want to find a keyword. We want to characterize hard disk, or we want to get the timeline of hard disk. So this is how we divide the forensic analysis, and it is a selection of specialized modules that execute one after another. This is a job example. In fact, this is one that was launched automatically. It's launched automatically when we get a case, and these are the models that are executed when we get such a case. It's an example. I won't get into each of them, but what you can see is what we are executing. We have a look at hypes. We do a timeline. We have a list of files that are in the hard disk. We see the cache activity, or the flash disks that have been plugged in the operation system. This is something that is done automatically. Many of the processes that we have to develop when we are analysts, sometimes we need to do them by hand. Well, these are all automatic as soon as we receive a case in the forensic lab. In fact, now you will be able to see that the analyst can start. The analysis can start to have a look at the timeline when the rest of the jobs are not over. So the analyst is able to start performing analysis, and he can focus the analysis and the fact of focusing on the analysis and not on the tools that are being executed in the background. Here we have some jobs that have been defined. These are modules, groups of modules, and this is just to show some examples of what the system is able to do right now. So to look for the emails in a hard disk, to draw some information, to pick some information from the servers and browsers, cookies, the Skype conversations. We support different social media to have a file list. And these are the common jobs for many cases. Apart from that, we have defined jobs for each system that is supported. In this case, it's Windows. So we have the recycle bin, we have the auto rip, and we not only support Windows, but also the system is also able to analyze other operational system. We have iOS here, with the cookies, with the WhatsApps in iOS. For Android, I think that we can't see the slide, but we have some jobs that let us analyze Android, and we come to this, and this is the one that I like the most, because this is the one that makes our system powerful, and now we'll see it during the example. This is the one that is called Indexation Module. The Indexation Module takes a look at these artifacts. If it's a .zip file, it gets into the file. If there's a RAR, it gets into the RAR file. If there are emails inside, it analyzes the attached documents, the metadata that are included, that are embedded in the zip file. So this basically analyzes the artifacts of the hard disk in a recursive way, and it lets us get into the system. We'll see some of the examples of this module. Here we have the execution of one of the jobs. In this case, it's the most basic job. It is the help job. We have help in the system in order to support the analyst, so that he knows what he is executing and with what configuration and on which disks. The RVT is not only a module, it's not only a program, but there's some kind of ecosystem behind. As we can do pipes, and as we can send its output to different systems, we have different systems that have this output. This would be the process with some of the systems that we have defined. The artifacts are parsed, the events registry, the Windows artifacts. So with each of the RVT modules, well, this ends up in a JSON or in several JSONs. We can do grabs to these JSONs in order to focus our research at a specific artifact where we are more interested in. And these JSONs can be injected to other systems. In this case, it would be Elasticsearch, or to use other tools that we have defined. in order to focus this research and route it towards the results. The RVT can help us write the reports, but it can support us. We would like to have a model to solve cases. In fact, we do have it, right? We do have it, but it's not very efficient to solve these cases. The only thing it says is, well, I solved the case, but it doesn't tell us how. So there we have the module. This part can, well, the RVT can support us, but the part of reporting the customer or the judge, the court, so to speak, is, well, and the RVT can't help us very much. So what do commands look like? Here we have the RVT. We need to say what morgue we are using at every single time. We have some values by default, so the morgue has already been predefined, all the default case, and we inform about the job that we want to execute. It would be the status job. We can see the indexer directory, and it would parse all the files and to take information including to these files and its metadata. This would be the text interface, but we also have graphic interfaces. In these cases, we can see a research of a keyword. This is the keyword bird in a graphic interface, and here you can see the results of the graphic interface. Not only that, but also a very interesting part that is starting to help us perform the analysis is about putting tabs. So we are able to see what are the relevant artifacts or the artifacts that needed to be looked at in the future so that they can be categorized, and we have the possibility of including remarks in order to recall that artifact, why it was important or why it had to be analyzed in the future. So another module is Kibana. As we are including our information in Elastic, we can take advantage of Kibana's power. In fact, we do it. We'll see it in the example to have graphics with many colors in order to solve the case, because colors are always fun and useful. And this is the case study. Well, this is an example that we've looked for in order to test the tool and for you to see the result of a process of analysis. Of course, this type of analysis is really time-consuming, and we can't show the whole process, but it's true that you'll be able to see the investigation highlights with our tool. For this, we've gone to Digital Corpora. This is a website that is focused on forensic information. There is a case that is this case of the owls. Well, it's an imaginary case, but it's related to some other real cases. So just to be brief, at a jurisdiction, it's not illegal to have owls, but it's illegal either to buy or to sell owls. So if there's monetary exchange with owls, that would be illegal. So the case is that we have two forensic images, one coming from a computer that the police has sized at a house, and an Android phone. And the idea is that we need to look for evidences because they suspect that these monetary exchanges have taken place. So from here on, we need to think of minimum questions that we have to answer. And in order to have these questions into account, well, we would be speaking about these 5 W's: what, when, where, who, and why. And how, for example, has a W too. So that would be the bonus. So what are we asking ourselves? So has this transaction happened or not? If so, where? So is it possible to find a place where this transaction has happened? When did this transaction happen? At what moment in time did this transaction happen? Did this transaction happen? Sorry, if we will be able to if we are able to find it, and who and how has performed these actions, just in order to include the the case investigation. First of all, we would need the source characterization. Now we'll see an example, but there's something important, because just to put an example, there was a case where we took for granted that the idea that we saw a specific case was correct. There's a team that has contributed a forensic image, and is it possible to conduct the investigation just with these models? If we do not do that characterization, maybe we are looking for transactions, looking for the word money, looking for the things that we're looking for, and maybe we see that it's not the computer that we had to analyze, because maybe that was not the right computer that had to be analyzed. This is important. It's important to have a characterization module, so that since the very beginning we can see what computer we are talking about, what user, what operation system, and so on and so forth. So let's see the result. Just keep in mind that one of the goals of the project is to minimize the human mistakes. Human mistakes happen. We make them constantly, and we will keep on making them, but we want to minimize this component. So this is why we want to automate processes so that they are written down, they are registered, and the sooner we can register the mistake, the better, so that we can correct it. In this case, it was the characterization module. This is the one that we analyzed first. And it's the first one that gives us some results, and we can see whether we're analyzing what we have to or not. Sometimes we have been analyzing what we shouldn't, not because we've chosen the wrong sources, but sometimes we do not control what sources we are sent. So here we have the two commands that we would need to characterize a hard disk, and in this case you can see the result of the commands. Here you can see that there was only one user, who is Sarah McAvoy. It's a Windows computer. We have the installation date and the last use date when it was shut down, and the logins and logops that the user had in the computer. So this is what we call system characterization, and the analyst should be able to control and should analyze that we are using the system that we should.
In the second job that we always launch is to get a list of files within the hard drive. The system automatically continues to launch jobs. If we tell the system that everything goes all right, this system moves on. And now we have elements to analyze already. So forensic investigation is not done live. We generate these text outputs and then we do our search there. But we are looking for maybe hidden in a subgroup of folders. Okay, that's why this artifact is used for. Right on top, we have the command that want to launch the system. So this is within the forensic process. And this is the process or the result that we get in the command line. These are the keywords we are interested in. We are interested in looking for boost transactions. And within the computer, there are information about owls. So therefore, this is the direction that we will be following. This is the right direction. We have our owls, and then we see that they are within downloads, within files, because there are people working with them apparently in the desktop, and then we can start, we can take it from there. So this is the command line. There are other interfaces, which are graphical interfaces, that help us see what has happened with those artifacts. On top, we have the event timeline, what happened with each of the files and when that happened. If we combine that with keywords, relevant words, and then we come out with the owl filter, and then also the timing when all those owls happened or took place, so we have a peak of information for us to investigate that over specific periods of time. We just don't want to investigate the whole period, so we want to focus on the end of January, early February. More graphical interfaces. These are keywords. And this is a video. So these are very short clips, 30-second clips. As you can see here, we have a keyword on top. And now we have the outputs from these keywords. And now we see this highlighting of the word matching. Metadata for each of the files. We were interested in a database detected by the system. So from the two sources of information, we can also make complex searches. For instance, a search telling the system, find this word, or what we're looking for contains this term. As I said, this is complex search. This is the output of the search. This is a very important point of our forensics. Well, it seems that someone wants to keep an owl alive, and they are looking for ways to feed that owl. Another module, we are kind of developing it to see how far we can get with it. We are very helpful. This is about using artificial intelligence techniques to identify owl images that do not contain the word owl. So we think, well, those techniques are really helpful, and hopefully they will help us and will help us reach long. So we could, I don't know, find any other do any other search depending on the keywords that we enter. So we have videos for automatic classification. This is a type of search for automatic classification. The results are only images that do not contain keywords. As I said, these are automatic classifications that are being made on automatic, while some of them are false positives because they are not purely owls. So this is a very nice classification because sometimes they also classify the owls by breed. So within the recycling bin, artifacts are found, even if they do not contain keywords, but are relevant for our research. So these are examples of the graphical interfaces that we have used. I will go quickly through them. You can see that we can classify the information as well as identify a time period we are interested in, so that we can see what happened over that period of time, and to focus the information in the relevant areas, more files, classification, different colors, different graphs, keywords identified, how to search them. Also interesting is seeing that we do not only find keywords in the documents, but also in the system events. So we have file systems, files that are created and destroyed, also browser events, or events from the journal that are more specialized within forensics. All these events are integrated in the system, are embedded in the system, and give us a timeline with all the events so that we can resolve our cases. other examples of graphical interfaces, what we can do with journal, others, with browsers. So lots of graphical possibilities helping us with our forensics. So this is a cloud concept. From some keywords, we can easily identify other keywords. One more example now. Browsers. This is the date when the browsers were visited. I just wanted to show you these examples for you to see everything that we can do in this, this system, this investigation has been published. If you're interested, you can really follow it and take a look at all the commands needed and interfaces needed. This is an interface to take a look at the strings and for you to see that we not only support Windows, does not only run on Windows but also on Android databases. And these are the conversations that we found within our case. So here we can already we are starting to resolve the case when the owls are being delivered, when the transaction takes place. It also gives us a date, it also gives us a location, and we can geolocate the time of or the place of the transaction. These are the conclusions of that case. Remember that what we wanted to know whether there has been an economic transaction of owls, and then we can conclude using the system, the commands, and everything that we have showed you, and the different lists. The conclusion that we reached is that there were transactions indeed. Actually, we know when that happened, with whom, and where the people decided or met. We didn't know whether there was any money exchange or not. So after visiting the park after that date, well, the person stopped looking for owls but started to look for how to feed an owl. So we, this is, then we will see what happens. It will be the judge who will decide whether there has been owl transactions or not, but it seems to be quite clear that there were some of them. So this is the system and our case. So the system is available, can be downloaded. We have GitHub. This is the code that's been published a few hours ago. We want to give to the community back something as we first got it from the community. So this is also uploaded in Docker. If you want to download it. This example investigation has not been yet published. I just didn't have time to do it. I will do it either this evening or tomorrow. So this is the system documentation, also available on the internet, how to install it. So we wanted the documentation to be quite comprehensive, with good detail about the processes that we followed, each of the systems that we support, Linux, Windows, iOS, the folder structure that we propose, and examples. So this case will be published very soon. And to finish, first of all, we'd like to thank you for your presence. So we have kind of balanced our karma with open source. We had kind of a debt with the community. We've been using open source for many years. We have only gave back some small scripts, and now we are happy to have given back a project that we are all the time using, that is highly usable, and we would like it to see growth and to meet all the characteristics on the screen. And we've been very happy to release it, to disclose it to you all here at RootedCON. Our next steps will be to continue developing new modules to complement it, also coming up with new artifacts. If you come up with an artifact that you are interested, well, let us know, and also creating new views or GUIs, also to improve incident response. And if any, we would be very happy to take any collaboration from you so that we can create a community around this tool. So thank you very much. We are happy to take any questions that you may have. Cannot see you? All right. We have 3 questions. Hello, good afternoon. Thank you very much for your presentation. Thank you for the tool. You will be saving lots of time and effort to forensic experts. If everything that you shared with us performs well, goes well, it will be wonderful. When I do that, that takes lots of time and effort. And very important, you shared with us typical mistakes. So with your methodology, well, you have minimized the number of errors, so thank you. Congratulations. Yes, everything that we have shared with you is performs well, and if something is not working, we will fix it. Everything we showed you is fully functional. Actually, we are been using it on an ongoing basis for a long time. If something does not work, it means that it is bad, so we need it to work properly. Hi, the module. So the module for recognition of artificial intelligence and images, is that yours? Yes, that is TensorFlow. We use the Google model, but we use TensorFlow, and we have identified, and actually we have downloaded some of them that we cannot disclose them, but there are artificial intelligence models specialized in child pornography. So any model that is supported by TensorFlow, that's what we use. So when we looked for keywords and you found a PDF or an image, you opened it. But if it is an email within a PST, how do you present it? What do you do with it? Well, that's a very good question. We have gone round and round that question. Actually, there are some modules to renderize. So they are exported to HTML and they are renderized there. So we went round and round to see how we could fix that. We are not talking about PSTs, but also other artifacts. PSTs, well, you export an HTML and you show it in HTML. That presentation at court, how is it taken? How is it understood? Is it taken on board? No problem. The other party says that is not. What does that come from? When it comes to working and exporting, we export all the elements that make it up. So an HTML is created to convert that output into something that can be visualized. But if you want that element that you're visualizing and analyzing, you may go back to the original element. No one shows a PST right away. Actually, you show a screenshot of email, and for instance, you can see that in an Outlook viewer. But you may use any other viewer the element is located, and you can show it with any viewer on your report. Often that is not a problem. At court, what actually matters is that all the evidence that you're showing is being supported by a source of information that you have access to, that you follow the chain of custody, and that can be checked by third parties. Actually, one of the objectives of this tool is to have an audit of all the commands that were launched, not only to help out the team of analysts, or if we evolve it so that the logs cannot be tampered, so that you have the full chain of all the actions that were conducted throughout the search. That is part of the process that we want to build up in that internal audit and that flow. Last question, please. Good morning. Well, I'm an expert. Well, actually, Roman was my trainer many years ago. First of all, I would like to congratulate you for that awesome tool. I work as an expert. Since I saw you're working on the case, you do not have an iteration. You only have one iteration, then you detect an IP, then you run the processes with that origin IP to see how many times the was logged in. So, do you manage those cycles somehow? So that is throughout the process. You mean traceability? Yes. Okay. Actually, this is a problem that we also had. That is to say, we had to document those cycles, the commands that we run, but also, yes, as a legal requirement. So the tool keeps a log of everything that has been done, of what has been run, of the keywords that we entered, of what we did. Well, I had some examples in that regard, but I just didn't have the time to show it to you. So there is a record, a log of all the commands that we have run on our analysis sources, and that helps us document the investigation and to support these cycles that we have just mentioned. So a quick question. Is there any machine learning behind that? No, joking apart. Have you thought about setting up any module marketplace? So where people propose needs, and then, well, different modules are proposed. Well, you would like to have new ideas, either coming from the community or from interested parties or companies. That is to say, to organize, create specific modules to resolve specific problems. We have released it to the community so that people can play around with it, they test it. That's why we have set up a Docker, see how much it is embraced, and how we will continue to use it. We will continue to develop it. But now that this is open to the community, we will find feedback or perhaps needs that we didn't even consider or thought of. So it will be wonderful to have that contribution and to listen out to new ideas. So thank you very much. We give the floor to Gonzalo.